Hello everyone, and thank you for joining me today to learn more about laboratory proficiency testing. There are a few topics that we'll be covering today in the area of proficiency testing. First, I'd like to cover the objective of proficiency testing, followed by the procedure for a proficiency testing program, outlining why it's developed, and a little bit about the procedures for the program from its inception to the laboratory receiving its end results. We'll then go into proficiency testing results, and I also have provided a copy of an AOAC participant report to cover all of the statistics that we use in the program. Then we'll move into role of the proficiency testing and quality assurance, role of proficiency testing and accreditation and certification, the importance of proficiency testing, and then we'll get into the specifics of the AOAC laboratory proficiency testing program. So first, the objective of proficiency testing. The overall objective is to improve analytical performance by providing an independent measure of the quality of the data. The role of proficiency testing and quality assurance. Well, let's look at self-improvement of the laboratory. First, it's to help estimate the relative accuracy and precision of the results compared to other laboratories. It's a great way to compare your results against a pool of other laboratories. It also helps to identify weak methodology that the laboratory might be using. And of course, proficiency testing can be used to detect training needs. If a laboratory is not performing well, it could be the technician, it could be the method, but at least you have identified that training needs to occur on one or both of those. It's also to upgrade the overall quality of the laboratory's performance. Now let's take a look at the role of proficiency testing and quality assurance as proof of competence of the laboratory. By participating in proficiency testing, you help prove technical competence to your customers. Proficiency testing results help establish international credibility for exported goods. And an important part of proficiency testing is that it meets the accreditation requirements for ISO 17025 that's used by the testing laboratory. It also meets certification requirements for certain GFSI certifications, such as SQF and others. Proficiency testing is also used to qualify vendors. Now let's talk a little bit about accreditation for laboratories. Laboratories usually head towards accreditation if they aren't already accredited, and they become accredited to ISO 17025. The current version is 2017. This is the general requirements for the competence of testing and calibration laboratories. This standard specifies the general requirements for the competence, impartiality, and consistent operation of testing laboratories. It's applicable to all organizations performing laboratory activities. Doesn't matter what the number of people that work there are. Laboratory customers, regulatory authorities, organizations, and schemes using peer assessment, accrediting bodies, and others use this standard in confirming or recognizing the competence of laboratories. Now, AOAC is on a different side. We are a proficiency testing provider, and as a proficiency testing provider, we are accredited to our own standard, and this is the ISO 17043 standard. 17043 is conformity assessment. It's the general requirements for proficiency testing. It provides all the criteria we need to run an accredited proficiency testing program. This standard specifies the general requirements for the competence of providers of PT schemes and for the development and operation of PT schemes. The requirements are intended to be general for all types of PT schemes, so it's not just for food microbiology, food chemistry, it's not just for our area. There's proficiency testing in all aspects of the scientific area, such as I ran into somebody at a meeting not too long ago that did proficiency testing on the hardness of concrete. So it does cover a large general area. 17043 currently has the 2010 version. However, 2022 currently has a draft. I believe that they are meeting again in November to further discuss the draft of the 2022 version. And every time a new version comes out, as a PT provider that's accredited, we have to make sure that we are meeting the requirements of any new criteria. Also, as part of a proficiency testing provider, we provide statistics in our reports for the results of the laboratory. Those statistics also have to meet international standards. The standard for statistical methods for use in a proficiency testing program is ISO 13528. The current version just was issued, and that's 2022. This document provides detailed descriptions of the stat methods for proficiency testing providers to use in designing proficiency testing schemes and to analyze the data obtained from those schemes. This document provides recommendations on the interpretation of the PT data by the participants in such PT schemes and by the accrediting body, the ABs. The procedures that are outlined in ISO 13528 can be applied to demonstrate that the measurement results obtained by laboratories, inspection bodies, and individuals meet specified criteria for their acceptable performance. And this standard is applicable to proficiency testing where the results reported are either quantitative measurements or qualitative observations on test items. So the testing laboratories, they're accredited to ISO 17025, and as a PT provider, we're accredited to ISO 17043, and our statistics have to meet the criteria of ISO 13528. So if you're an accredited laboratory, you have to have a quality system. And within that quality system comes a lot of documentation, such as your quality manual, your standard operating procedures, all your methods, policies, etc. In addition to that, accreditation requires laboratories to hold internal audits as a check on their quality system. This is usually done by a quality assurance manager. You'll have to set forth a quality control program. And finally, part of accreditation, in addition to many other criteria laid out by the accrediting bodies and the ISO standard, is proficiency testing. So let's switch gears a little bit and talk about the flow of a proficiency testing program. What is a proficiency testing program? Well, randomly selected subsamples of test materials are distributed to participating labs for concurrent testing. The test materials have to be homogeneous and stable for the time period and storage conditions during the shipment and analysis. And we do a lot of homogeneity and stability on all of our proficiency testing samples. They have to meet homogeneity prior to being shipped, and they also have to meet stability in order for us to provide statistical information on the results for the laboratory. Next, participating laboratories analyze the test materials after they receive them. They then submit results to the proficiency testing provider by the deadline previously set forth. Once the data has been gathered, statistical software analyzes and calculates results. Laboratories are assessed on the difference between their results and a determined assigned value. A performance score based on a Z-score is calculated for each laboratory for each test. Then reports are distributed to those participating laboratories from the round. Test materials are distributed on a regular basis, and this provides an opportunity to measure performance often and also identify and correct problems. If laboratories receive Z-scores that are greater than 3, that usually is a nonconformance, and the laboratory has to perform a root cause analysis, corrective actions, etc., and usually will need to order an additional set of samples from that round. We make those available. Let's now talk about results. As I mentioned in the previous slide, z-scores are the performance indicator for proficiency testing. And the z-score is the reported value of the analyte by the laboratory subtracting the assigned value, which is the best estimate of the true concentration. And this assigned value, what I'll get into in a little bit, can be determined in a couple of different ways. And this is then divided by the estimate of the variation, the standard deviation. In the table below, you can see what a z-score represents. A z-score less than 2 is satisfactory. A z-score between 2 and 3 is questionable. And a z-score greater than 3 is unsatisfactory. And usually when a z-score is between 2 and 3, the questionable rating, it is a warning. It's, hey, we need to take a look at this. A z-score greater than 3 is an action. It's unsatisfactory, and you need to understand why your z-score was greater than 3. That's why there's the root cause analysis and corrective action, etc. Now, this z-score formula was based on 13.528. However, the new 13.528, which just came out, has a new formula. It's represented the same. It's just a little bit different statistically. The resulting z-scores still have the same meaning. A result less than 2 is considered to be acceptable. A result that gives between 2 and 3 is considered to give a warning signal, and greater than 3 is considered to be unacceptable or an action signal. You need to take action at that point. Now that I've explained the z-score and how laboratories evaluate performance, I wanted to provide a sample of a report that's issued to a microbiology AOAC participant. This is a report that's provided to the laboratory after they complete a round. These laboratory reports meet the requirements of 17043 and 13.528 for the statistics. Items that are covered within our report include general information about the round, when it was shipped, analytes that are included, and the due date. In addition, we provide information on how the test material was prepared, and if samples were duplicates, we identify them at that point. Also required to be in the report is a list of the analyses requested. This particular program is a pathogenic microbiology program. It has 4 samples for qualitative analysis and 4 samples for quantitative analysis. The organisms used for qualitative are Salmonella, E. coli 0157H7, for which you can also report the presence or absence of Shiga toxins, and also Listeria. It also has numerous quantitative, such as aerobic plate count, coliforms, generic E. coli, coagulase positive staph, yeast and mold, bacillus, enterobacteriaceae, etc. Very comprehensive program. But usually if you're a laboratory, you're testing most of these. We also provide information on the calculation and interpretation of the z-score that a participating laboratory receives. Again, this is the current z-score formula, but we will be moving into the 2022 13.528 formula, which is just represented a little different. We also provide a detailed discussion of the results, which samples were negative and why. We also provide information on the test kits and methodology used, so that laboratories can identify methods that may be performing better than others. Here's just a table of that comparison for Salmonella, E. coli, Listeria, and then we move into discussion of the quantitative data. It looks like things were rearranged when this was converted to a PowerPoint, but it still provides what the data would look like. We provide information on the assigned value and also the standard deviation from the various methods used. After I cover this technical report, we'll go into an individual laboratory's results, which also display this information. In addition to just listing all the statistical information, we do provide z-score plots and distribution plots, which I will also in a moment. Part of the report also includes the homogeneity data. This page represents homogeneity from the round for the Salmonella, Listeria, and the E. coli 0157H7. Everything passed. We also provide a copy of the instructions that were originally sent to participants of the round within the report. Here is the homogeneity from the report. This is for the quantitative data. As you can see, APC, coagulase positive staph, Bacillus cereus, and coliform plate count. Within this, it's also broken down between the samples, as 2 samples are duplicates, such as 5 and 6, and 7 and 8 were also duplicates for this round. A continuation of the homogeneity, again, just indicating everything had passed for the round. Now let's take a look at an individual laboratory's results. This accompanies this technical report and is specific to each laboratory. This is the page for the qualitative results. It covers the Salmonella. It also lists the method that the laboratory used, and under the reported result column, it indicates the negative or positive, also absence or presence. The far column indicates the expected results, and in between the two is the percent of labs agreeing with your reported result. As you can see, there's a high degree of labs agreeing with each other. This is just the next page of the qualitative data and shows the Shiga toxins and also the Listeria. Laboratories can report for just the presence or absence of Salmonella and the Listeria, or they can also get more detailed and they can provide the species that's used and or the O or H antigens for the Salmonella. Next, we have the quantitative results. We provided a lot of statistical information to our participants. The laboratories are provided a confidential site identification code that only the laboratory knows, and AOAC. This site code is used to represent the laboratory in reports. As you can see, this laboratory performed very well. This report lists the number of laboratories that reported for that specific test, the reported result from that laboratory, and that's then converted into log 10 for the purposes of the statistics. We provide information on the quartiles, the median, then of course the assigned value, which for this program is based on consensus values because we have over 200 laboratories in this program, and the standard deviation, and the resulting z-score for that laboratory. Again, a z-score, anything under 2 is great. The closer to 0 for a z-score is best. If it's a negative z-score, that indicates how far below the assigned value you were. And if it's a positive z-score, that indicates how far above your counts were than the assigned value. A perfect z-score would be 0. Again, these are just the rest of the organisms for this particular program: the yeast and mold, bacillus, and Enterobacteriaceae. If there's not enough laboratories reporting for a specific organism or technology, such as the MPNs, then we'll indicate in our notes that the z-score was not computed. We also provide a graphical display of the data in the form of z-score plots and also histograms. This z-score plot from the same laboratory shows the laboratory's individual result as the dot, then all of the individual hash marks to the left are all the other participating laboratories' results from the round. And then the box indicates the quartiles. This is a histogram of the same information, just showing where the results lie. If anyone would like a copy of these sample reports, they are available on the AOAC website, or you can send an email to lptp@aoac.org, and we'd be more than happy to provide a copy of any of our program's reports. The importance of proficiency testing. Well, overall, it provides an independent measure of quality. It's a great assessment of a laboratory. It really is. Also, proficiency testing meets customer requirements. It meets accreditation requirements and also certification, such as SQF and other GFSIs. Proficiency testing also demonstrates technical competence for the methods, for overall performance of the laboratory, and even the individual laboratory personnel that's doing the testing and reporting the results. Now let's talk about the matrices. There's a lot of proficiency testing programs, and there's a lot of matrices that are needed by the industry. However, it must be noted that while matrices are important, it's impossible to have a food matrix for every single type of food. Therefore, proficiency testing providers, like AOAC, tries to develop programs with a general food matrix that can be used across many methods. Again, when selecting a PT program and the matrix, you want to make sure it's fit for purpose for your laboratory. And I want to cover some of the differences in some of the proficiency testing matrices that are out there in addition to the programs. Let's take a look at food microbiology. A lot of other proficiency testing providers just provide a lyophilized pellet to the laboratory. The laboratory then has to take that pellet, mix it, and make sure that that sample is homogeneous before they start the analysis. Now, it's a pain to make your own sample. It increases the possibility of error. And people forget that there's cost involved with that preparation step that's not outlined when you join that particular program. Homogeneity. Let's just hope that the sample is prepared and mixed appropriately before you begin the analysis. Now, on the other hand, you have programs such as AOAC that provide real food matrices. The samples arrive ready to analyze at the laboratory in an actual food matrix. This decreases the possibility of error. There's no additional cost because the samples, again, arrive as a food product with homogeneity already being completed prior to the samples even being shipped. So there's no worries by the laboratory that's about to complete the analysis. AOAC also sets itself apart from other PT providers because we provide a lot of comprehensive programs. Many laboratories, when they're testing for food chemistry, they're not just doing moisture, they're not just doing fat, they're not just doing protein, they're doing moisture, fat, protein, fatty acids, you name it, heavy metals. So AOAC designs its programs to be truly comprehensive and to provide analytes or organisms in a broad range. As you just saw in our microbiology program, it's not just salmonella, it's not just E. coli, it's all of those. Now, we do have different programs that have different subsets, but still, for the most part, they are all comprehensive programs, and that allows for a laboratory to report for as many or as few of the organisms or analytes that they need. Again, AOAC samples are more like routine samples. If you're a micro lab, your routine sample is not a lyophilized pellet. It's usually a food product. So it's in the best interest of the laboratory to have a proficiency testing program that offers real food product matrices, such as the AOAC program. The AOAC Laboratory Proficiency Testing Program is accredited. We are accredited by A2LA, and here is a copy of our certificate number. If anybody would like to look up us on the A2LA website, it shows our certificate of accreditation in addition to our scope of accreditation, which shows all the different programs and what we are accredited for. A lot of our programs were developed from feedback from international experts, through working groups or advisory panels, stakeholder interests, etc. Currently, the proficiency testing program at AOAC is focusing on food safety. We have programs in food microbiology, a lot of programs in food microbiology, both pathogen and pathogen-free. We offer a couple of different food chemistry nutritional labeling programs in both meat and cheese. We have an infant formula program, which is an extremely stable matrix that does not have to be shipped with ice. We also have a pesticide residue in the fruits and vegetables. That's a great international program with a lot of laboratories. And we just more recently developed a Listeria swab program. This is an Listeria environmental swab, which laboratories are using for surfaces. And more recently, through the AOAC Cannabis Analytical Science Program, we have developed a program for cannabis and hemp. I do appreciate everyone's time today. And please, if you have any questions about proficiency testing in general, or you would like to learn more about AOAC's program, please visit the AOAC website or email the proficiency testing staff at lptp@aoac.org. Thank you, everyone.